Okay, so here's another implicit differentiation example, and now we're going to look at a little kind of, how this applies in the bigger picture idea. And so we want to show that the slope of dy dx is defined at every point on the curve of 2y equals x squared plus sine y. So notice that we've got y's on both sides. Notice that there's a y inside of the sine, which makes it a little bit tricky. If it wasn't in there, we could maybe solve for y and then take derivative. But since it's inside there, we're going to have to use implicit differentiation. Okay? So what we're going to do is we're going to dive right on in here. We're going to look at the derivative of 2y, and the derivative of 2y is 2 times dy dx. Okay? And then we're also going to look at, on the other side of the equation, the derivative of x squared, and that's going to be 2x, plus the derivative of the sine of y. So the derivative of the sine is cosine times the derivative of dy dx, or the derivative of y, which is dy dx. Okay, so this is what we've got going on. This is our situation. And notice that I've got dy dx on two different sides of my problem. So I'm going to go ahead and move the green one over to the left, and in the process I'm going to go ahead and change it to the blue color here. So 2 dy dx minus cosine y dy dx equals 2x. So here's my setup. I've got all the dy dx's together on one side. So guess what I can factor out of both pieces? You guessed it, dy dx. So now this is kind of like an algebra problem of old. So I have dy dx times 2 minus cosine y, and that's going to be equal to 2x. And then from there, I'm going to just take and divide both sides by 2 minus cosine y. So dy dx equals 2x over 2 minus cosine y. Okay, so what we want to do is we want to show that the slope is defined at every point. Well, the only place we're not going to be defined is where we get 0 in the denominator. Okay, right here. Where are we going to get 0 in the denominator? And we only get 0 in the denominator when the cosine is equal to 2. Well, guess what? The cosine always bounces between 1 and -1. So there's no way that we're going to get a 0 in this denominator. And since there's no way we can get to 0 in this denominator, we can say that 2x over 2 minus cosine y is defined at every point.